I'm going to be talking about tag synthesis and lipolysis. Tag synthesis is exactly what it sounds like. We're synthesizing tags. This occurs in the fed state when we're eating. We eat more glucose than we need, so we turn that glucose into fatty acids, and then we combine those fatty acids with glycerol to make a tag. So tag synthesis starts off in two ways. So if you're in the liver, you have an enzyme called glycerol kinase that can turn glycerol into G3P. If you're in adipocytes or muscles, you do not have glycerol kinase. So you have to start with DHAP and then turn it into G3P. But once you get here, the steps are the same. So G3P turns into phosphatidic acid. Phosphatidic acid turns into a DAG, diacylglycerol, and then DAG turns into TAG. And if we ate a TAG, it'll just go into a chylomicron, through the lymph, through the blood, go all around the body, dropping off tags, especially in adipose tissue, and then it'll end up in the liver. If the tag was synthesized in the liver from scratch, the tag will be sent through a VLDL to adipose tissue. It'll be dropped off there and stored there. And also, tags can just be made within adipose tissue, just from scratch, from glucose. Now, the opposite pathway is tag breakdown or lipolysis. So you're breaking down tags into free fatty acids and glycerol using hormone-sensitive lipase. Hormone-sensitive lipase is stimulated by glucagon and phosphorylation, because phosphorylation just means you're adding a phosphate onto a molecule, and that's always happening when glucagon's high. Glycerol will go to the liver for gluconeogenesis. Free fatty acids will go to the tissues to be used as energy, or it'll go to the liver to be used as energy in fasting or starvation, or they'll be turned into acetyl-CoA and then go through ketogenesis. Inhibitors of tag synthesis is glucagon, because that means tag synthesis is happening in the fed state, so glucagon and phosphorylation signify fasting, and so does epinephrine. Tag synthesis is going to be stimulated by anything that comes from fatty acid synthesis, because we need fatty acids to make tags. So that includes insulin, because we're in the fed state, glycolysis, because that's turning glucose into pyruvate. All these enzymes will stimulate fatty acid synthesis, which will stimulate what comes next, which is tag synthesis. Hope that made sense.